39 from 4.3. Okay. Who was first? I forgot. I'm sorry.
I think I think I
Yes.
was first. And
Yes.
yeah, could we do from 4.3? It's a Newton's method question, and it's the.
But that's not 4.3. It's 4.
Oh no, wait, I'm done. That's 4.8.
Yes. That's okay.
You said 4.3 earlier.
Yes.
Messed me up.
That's fine.
No, so it's the. What's it called when there's a 4 before the square root? Is it
the fourth root?
Fourth root of 73.
Of
73.
73. Awesome. Awesome. Okay, so the question is, how do I use Newton's method on this? Very simple. We look at this. So basically, what can it be? Remember, I have to have an equation. If I don't, after the equation, I have to have a function. So how from here I get the equation that I need and then identify the function I need? Does anyone have any idea? It's okay if you don't.
I'm pretty sure I know. I think it's x to the 4th minus 73.
Yes. Yes.
Oh, it equals 73?
Yeah, it doesn't matter. It's the same thing. X to the 4th minus 73 equals 0. So this is our equation that we want to solve. And this is our function now. So the function f of x is x to the 4th minus 73. Perfect. So now f prime will be 4x to the 3rd. N of x will be x minus x to the 4th minus 73 divided by 4x to the 3rd. I will have to say that if f is continuous on whatever I'll find in a minute, and I will find that it changes sign. It has to. Okay, so I'm going to share my screen. Where are you guys? I found you. Okay, good. Good. So I didn't mean that. Okay, so I know that 73, the square, I mean, it's the 4th root. I have to start somewhere, right? So I will enter the function, and the function is x to the 4th minus minus 73. And now I have to put in some numbers, right? So where do I start? Because the square root, I know it's the 4th root, but the square root of 73 is less than 9, because 9 times 9 is 81. And the square root of that is 3. So I know I have to start somewhere with 2, 3, 4, 5 in that area, so I don't waste my time, right? So let's see 2, let's see 3, and it's done. So I know that there is a solution between 2 and 3. And the function is continuous. It's a polynomial function. So I have 2 and 3. And I have f of 2 is less than 0. F of 3 is positive. That's all I needed for now. Because what I'm doing here is I am stating the IVT. If the function is continuous on an interval, 1 unit interval, not wider, can be smaller, but not wider than 1 unit. F of 2 is negative and f of 3 is positive, then IVT guarantees. So there is a C in the open interval 2, 3 such that f of C is 0. So again, remember, IVT does not have any differentiation in it. It comes from chapter 2 from continuity. Okay, so I will say, obviously I can start, it doesn't matter. I can start with 2 or I can start with 3. This quantity is not 0. I'm going to say x, the first iteration. For me, this is the initial value. The book denotes this by x1. It doesn't matter. It's up to you. If you want to say that this is your first iteration, I like to say that this is my initial value. I don't consider this an iteration, but it is an iteration, actually. So it doesn't matter. It's up to you. So I'm going to say I start with 2. And then the rest, again, do not delete the function because you already put it in. So just insert, second and insert, and put the x, subtract. Don't forget parentheses around everything at the top. Don't forget parentheses around everything in the denominator. 4x cubed. Close. And then start the whole process, which is click, 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 basically. Okay? We go to y1, we click, we call y1. I want to start with 2. And then I get our first answer, 3.78125. And then from this moment on, I just copy, insert just one time, just at this level, insert the previous answer, and I get x sub 2, 3173501,942. I continue, and then I get x sub 3, 2.951140203, and I continue like that forever till I stop. So x4, 29234122362. Okay, probably this is it. x5. It could converge in less steps if we start at 3. It doesn't matter. So 2.923012868, 12866. Yeah, I'm pretty sure the next one will be identical or close. So 2, 4, 6, more than enough. So I'm going to stop. I'm not going to write this one. It's a waste of time. I already have 6 digits. Unless they want 8. But if they want 6, I will stop. I will not write the next one. Any questions on this? Is this clear?
And just to clarify,
Yes.
You stop when it starts repeating?
6 digits, more than 6 digits are identical.
Okay.
Because it
Can
says,
you find?
yes,
Oh,
go ahead.
no, it was a different question and you were still talking. That's my bad.
No, that's okay. But is this clear?
Yeah, I just had another question. So just to clarify, so you use the original function and graph it to find
No, I'm not
the
graphing it.
initial value?
I'm not graphing it. I'm plugging in numbers. I did not graph x to the 4th minus 73.
You just plug in numbers to find the initial starting value.
No, to find for a continuous function where it changes sign.
Okay.
Then I know that this is the interval that has a solution. There may be other intervals, I don't know. For this function, no. But for other functions, there may be other intervals where it has other solutions. But for this one, I found between 2 and 3 a solution because the function is continuous and it changes sign. Intermediate value theorem says if a function is continuous on an interval and it changes sign, it must be 0 in that interval. Because a continuous function cannot go from negative to positive without crossing at 0 somewhere. Or it cannot go from positive to negative without crossing the x-axis somewhere, because it's continuous. In other words, it touches each and every intermediate value, one next to the other. It cannot jump over the x-axis. Is that clear about the intermediate value theorem?
Yeah, I think so.
Okay, perfect. Other questions here? Okay, who's next? We're ready for the next question. You may be muted. Anyone? If not, I'll go through this. But I thought we had more questions.
Yes, I had a question.
Yes, I'm ready.
Okay, this was from WebAssign,
Yes?
and it's 1.7, and the first one was
Which number so everyone knows?
4.
Good. Ready?
Yes, it's the perimeter is equal to 120i divided by I squared plus I plus 1, and you have to find for what intensity is P a max.
Okay, so let's look at the I again, the function again, if you'd like.
Okay. P is equal to 120i divided by I squared plus I plus 1.
Okay, perfect. And we want to find the max min for P.
Yeah, the max.
Okay. We still have to show. So I don't care what it is. I still have to show what I'm getting. Good. So I cannot be negative because I'm assuming that this is the light intensity or something, right? So are we given an interval? But definitely positive. Good. So all we have to find is P prime of I. Remember, again, always look at the function, analyze it, and say, is there anything I can do to simplify this? Yes, I will put 120 in front. It can wait patiently because it's a product, and nothing else follows. This can be rewritten as 120 times I over I squared plus I plus 1. I don't want to waste my time with this. It can wait patiently. Top prime is 1, so I squared plus I plus 1 minus top times the denominator prime, which is 2I plus 1. Of course, over all this squared. Okay, next, I continue. I squared plus I plus 1 minus 2I squared minus I over I squared plus I plus 1 squared. These two go away. I squared minus 2I squared is negative I squared. And plus 1 over I squared plus I plus 1 squared. You know I'm allergic to negative leading coefficients. Okay. So this cannot be undefined. Or if it is, it will be undefined at the same point where, or points where P is undefined. So who cares? Those cannot be critical numbers. So P prime of I is 0. I will write it here so everyone knows that I did not forget. None. And from here, I have I equals negative 1 and I equals 1. But we are talking about intensity here, so of a light or light. So only I equals 1 is possible. So I go back to my table that I did not create yet. I don't know what this gives. I don't care what they're asking me. I need to see what I'm finding. Okay. I have to study the sign of the first derivative. Well, since I is positive, I refuse to study the sign of this piece, and I refuse to study the sign of this piece, and I will only study the sign of negative I minus 1. So when I plug in 0 here, negative with negative 1 will be positive. On the other side will be negative. Now I know this is indeed maximum. Guaranteed. Guaranteed. Because this function has a critical number and the derivative changes sign. In this way specifically, from positive to negative. So this has to be a maximum. What is the maximum in case they're asking me? It will be P of 1. 120 over 1 plus 1 plus 1. So this will be 40. And please do not forget, I don't know what the intensity is measured in lumens, or I'm not sure, whatever they're giving us. Never forget measurement unit. Whatever it is, you have to write it here. If it's meters, if it's centimeters, if it's feet, if it's inches, whatever it is, you have to write it here. So I didn't tell me what, that's okay, so I'm going to say lumen. That's the intensity. I don't know what P is measured in. So maybe I shouldn't write anything because you didn't tell me what it is. So that's okay. But please, so intensity is in lumen. I'm not sure what P is measured in. But, so let's not just invent stuff. So please always write the measurement unit. And now this is guaranteed to be 1, and that will be 40, whatever that is. Very good problem. Any questions? Are all steps clear?
Yes.
So I could have determined also here I could write -1, but that's not the case because I has to start at 0. So I equals -1 would be somewhere here on this side of the table. Who cares? It's not in the domain. Good. Excellent question. Anything else? All steps clear to everyone? As a friend of mine says, we are running a clean ship here. So I want my ship to be clean. Okay. Next question. Anything you'd like to ask? And I'm on page 3. Anything else you need help with? Anything? Anyone?
Can I ask a question about
Anything.
Yesterday's notes?
Yes, I'm ready. Yes, of course. Yes, yes, yes.
Let
Awesome.
me go back to what page it was. 1 second. It was the arctangent question, Newton's law. I think it was page.
Got it.
Okay, 12.
Yes, got it.
I just wanted to see, so that last part in x equals x minus arctangent x over top of the derivative. I just wanted to see what you put in the calculator.
Yes.
I was trying to do it by myself.
Yes. Brilliant. Yes, thank you. I really appreciate that. Thank you, thank you, thank you, thank you. It is very critical. Yes, very important. That is the most difficult part in Newton's method. And I'm not kidding. The rest is just a piece of cake. But I fully agree this is the most difficult part. Okay. So first we have to have the x, and then minus, and then left parenthesis. And we have arctangent, which is second tangent, x, and close the parenthesis. And then minus x squared, and then plus 3. Close the parenthesis. This is for the numerator. Divided by, open another. And now this is crucial. It's 1 divided by parentheses, 1 plus x squared, close. And then minus 2x, and then close again. Is this okay?